We're going to be doing two basic processes today. One is going to be changing from radical exponents to rational exponents. The other one is changing from rational to radical. We have a process of doing this because there are times when some problems are easier to do with rational exponents, some are easier to do with radical exponents. Okay? A radical expression looks something that has a radical sign in it. Okay? When we're talking rational exponents, we're talking about something that may look like this. Like x to the 1/2 times y to the 2/3. Okay? This is a radical expression. This is a rational expression. What? Yes, you may. Okay? You may. Just like if I told you to find 81 to the 1/4 power. That may be a little difficult, don't you think?
Yeah.
Okay? Well, you could actually use your calculator and find it if it was a exponent such as a rational one, because you have on your calculators you have a like y to the x key. You could put in 81, hit that y to the x, and then put in the exponent of 1/4, like parentheses 1/4, and you could find the answer, which happens to be 3. Okay? If I was to simplify it. You are more than likely easier to solve it if it looks something like this. The 4th root of 81. Because then you could do the 4th root, and if I prime factored this, which is 81, which is 9 times 9, which is 3 times 3 times 3 times 3. If I put a 3 to the 4th in there, isn't this easy to simplify? Should be by now, which gives you then a 3. So I need to be able to have a process to change it from this to this, or this to this. Okay? Well, here is the process to do that. You get out your eraser and you just erase everything. See? Changed it. Well, in some cases, some people just never write anything down, so they have nothing to erase. Changing from a rational exponent. Yep, we're going to go from rational to radical. Radical, dude. Okay? Going from rational to radical. if I'm going to go from a rational exponent to a radical expression, the denominator becomes the index of the radical. You remember where the index goes?
In front of the square root.
Not in front,
In
in that little v. So this comes down here, becomes a 4. This becomes, the numerator becomes the exponent on the number or letter that's there, so I'd have 81 to the first. That's how I go from rational to radical. So if I had x to the 2/3, and I wanted to change it from a rational exponent to a radical expression, where does the 3 go?
outside in the V.
Okay. So it comes here. Where does the 2 go?
Behind the X.
As in,
Exponent.
you've just changed it from rational to radical.
Wait, now what are you adding to it? Yeah.
So if I had multiple expressions like x to the 2/5, y to the 3/5. Well, first of all, I have to make sure that these are common denominators. Are they in this case?
Yeah.
Yep, they are. So what happens with the 5s? Okay, so I write my radical symbol. The 5 becomes the index. What happens with the numerator?
X squared, and y cubed. Now what if the denominator is unseen?
Then you're going to have to find a common denominator. Okay, so
Let me know how to change the numerator.
probably. So you're asking what happens if I have a to the 2/3, y to the 1/5. So I would have a common denominator of 15. So go from 3 to 15, what do I have to multiply by on the 3? So what do I have to do with the 2?
Multiply by 5.
So I have a 10.
Yeah.
If I wanted to go from 5 to 15, what do I multiply the 5 by?
3.
So I take 3 times 1, which is going to give me 3. Do I have a common denominator?
Yep.
Which means I have a common index now, don't I?
Yep.
So that index, the denominator becomes the index. And I'd have x to the 10th power, y to the 3rd power. Okay? Is that so difficult?
No.
Not until you get your assignment,
Yeah.
right?
Then they start throwing negatives and they start dividing them.
And
they're
numbers.
tracking.
And some of those things we have talked about numerous times, and it just...
Numbers. Yeah, but you've got this in my brain, and this is what's gonna be on my homework, and then when I show up and it's not on my homework, it's just like, oh,
Just like yesterday when they were adding, when they were adding.
And they had big parentheses and stuff, and I didn't know what to do with that. Yeah.
It's just combining
I should
it.
do it.
Yeah,
Yeah, it's hard.
yeah,
When you-
it is.
That's hard.
No.
What's the hardest one?
Why don't we take geometry first?
Can I just color for my course?
Who's good at that? What is the hardest one? Right to the back. I didn't even do it.
Probably
Yeah, why
calculus,
did I go to
which
school
we don't...
Geometry first. Cool, so we should go.
Okay, we're going to change from a radical notation to rational, which means if I had the radical that looked like this, when we went from the other way, didn't the index come from being a denominator, right? So if I take a simple expression such as this and want to change it, then this index becomes the denominator.
Am I leaving this out of fractions? Are you guys fun? What are you talking about? Where's the book down?
Like, yeah, can it be improper?
Yes?
I think, okay.
So I'd have x to the 5/4, y to the 3/4. Okay?
Hey, that's not too hard.
What, improper?
Is this all?
Oh, no.
Oh.
You know I'm going to have to throw other things in here.
Please don't.
Do you want us all to fill the
Can we just not?
We already been clear.
Sure.
You want us back? That's
Sure.
surprising.
We're taking this cost over next year.
Okay? We all right with that?
Yeah.
So if I had this,
Oh, that's.
if I wanted to change that to rational exponents,
You'd have x 1/3, y 2/3, z 2/3.
See, was that hard?
Can we just not add anything else to it now?
No, now we gotta add them together.
Yeah, why do we gotta add more together? I mean, add something else to it.
because that's why we do it to begin with.
Time out. Never mind, I'm not gonna answer this one.
What?
Stupid question.
What?
I'm not gonna answer.
No thing is.
So is that like solving it then?
No, that's just simplifying it. That's just converting it from
So wait, we have to
radical.
solve it after this?
Yep.
What?
Wait,
I
what
thought
did
we
you
said
say?
how do you
Bracket
solve
that you
something
get.
with
Bases are
brackets
defined.
like that?
We should.
Oh, that was good, Karen.
Can't handle it.
I bet I.
Oh my.
I don't like. When we're not together, we can say.
I don't like this anymore.
If I had to simplify this,
Well,
This was my friend, so you're not.
okay, it's a little difficult to do it right now because you have different indexes in the radicals. Would you agree?
Change them though, just.
But I can change those so that they are fractions, correct? Which means I could have x to the 1/2 times x to the 2/3 times x to the 1/4.
Yeah.
don't worry, I'm caught up now.
But caught up to what is what I'm wondering.
Dominators, yeah, can we just call them dominators?
Dominators.
We have to have all the same,
Okay?
Dominators.
If I were to multiply these together,
Dominators.
don't I have to add the exponents?
Yeah.
Oh.
And to add them, you would have to have a common denominator.
So I'm gonna have to end up making a common denominator of all those exponents, right?
So 12.
12.
I don't understand.
So I was right, you do have to have the same denominators, can't say it right.
So going from 1/2 to 12ths, what is?
6. 6 12. 8 12. 3 12.
Dude, someone actually. That's a lot of mental math.
14
No,
and 17 over 12.
So if I added all of these, I have been told that this is 17 over 12.
Sure.
Yep.
Wait.
Okay?
Yes.
Can I now write this as a single radical?
Probably.
Yes.
I'm guessing it's gonna be x.
We're
or
gonna find
12
out.
on the outside, and then x to the 17th power.
Right?
Yep.
Can I simplify that?
Probably.
12 can go in there once with,
12 can go into here once, so I have an X out here.
and then an X to the 6.
An index of 12, and an X to the 5th inside here.
Wait, why is there a
Yeah, why do you do
Because
that?
there's 5 left
Because
over.
12 goes into 17 with 5 left.
This is 17?